Hey kids, this is example 6 in 7.5. I know this section has so many examples, but looks like we're coming towards the end here of 7.5, okay? Let's start with my toddler joke of the day. Okay, the toddler joke of today is, why did the TV cross the road? Why did the TV cross the road? Because it wanted to be a flat screen. All right, here is example 6. Write each trigonometric expression as an algebraic expression containing u and v. Give the restrictions required on u. So let's start with example A. Now keep in mind, this example 6 is very, very similar to example 4. See this example 4 from previous videos? But instead of numbers, it just has u and v, and that's not really important. If you understand the concept, then it's not a big deal. Okay, so let's recap what we did in example 4 to give you an idea. So in example 4, remember we let this one be alpha and this one be beta right here? We're going to do the same thing. Okay, this is alpha, okay, and this is beta, and we draw two triangles. Sometimes you can't draw a triangle, then just make a dot. Here we go. So let's make this right here. Let alpha be sine inverse of u. So this is alpha. Then because it's just a variable u, technically I can draw it in quadrant 1 or 4, but why put things in quadrant 4 when I have to deal with negative, where I can just use quad number 1? Sine is going to be opposite over hypotenuse. So I have to do a little bit of work to find the adjacent, okay? So it's going to be a squared plus b squared equals c squared. Well, c squared is 1. A squared is, let's say, u squared plus b squared. So I'm going to solve for b. So b squared equals 1 minus u squared, square root. So as you can see, b is square root of 1 minus u squared. Now, I know because I put it in quad 1, everything is going to be positive. Okay, so that's alpha. Now I'm gonna need to also draw another one for beta. Okay, so let's make this what ink? Black ink. Here's beta. Let beta be cosine inverse of v. And again, because v is an unknown variable, you can draw this in quad 1 or quad 2 because that's the restriction for cosine inverse. But why make it difficult, right? So cosine is adjacent over hypotenuse. So I need to find this. And it's the same basic math like over here. So here we go. It's going to be a squared plus b squared equals c squared. C squared is 1. This is v squared plus b squared. So when I subtract both sides, I have 1 minus v squared. So b is going to be square root of 1 minus v squared. So we're going to put 1 minus v squared. Cautiously, okay? I don't want you to write fast because the u's and the v's, they look the same. But when you put them together, you can't multiply if they are u's and v independently. So what am I doing? I'm really now writing sine of alpha plus beta. Okay, so sine of alpha plus beta, which from my identity, yes, write down the identity. I'll wait for you to give you a minute to get a head start, or maybe 10 seconds to get a head start, and then I'll catch up with you with just the identity. So right now, just give me the identity. Okay, so hopefully this is what you wrote. Sine of alpha, cosine of beta, plus cosine of alpha, sine of beta. Okay. Well, I have alpha. Alpha is this one, and I have beta. Beta is this one. But now I just have to plug it in. Okay. So sine of alpha is, sine is opposite over hypotenuse. Cosine of beta is, beta is over here, so cosine is adjacent over hypotenuse, plus cosine of alpha. Alpha is over here, adjacent 1 minus u squared over 1 times, okay, sine is over here, have opposite 1 minus v squared over 1. Well, it looks like everything is over 1, right? So let's get rid of the ones. Okay, so it's u times v plus radical 1 minus u squared times radical 1 minus v squared. Well, guess what? There isn't much you can do, right? So technically you can box this up, and if you feel like multiplying these in the radical, you can do that too. I'm about to sneeze, so hold on tight. Excuse me. Okay. Well, you don't have to, because you can't really simplify. So even when I put it under one radical like this, and yes, that's the same, okay? Guess what? I can't really simplify to make it any prettier. So I will accept 2 separate radicals or 1 big radical. It's really up to you. And that's kind of how we use u and v for this one. All right, let's move on to example 2. I'm sorry, not 2b. Okay, here we go. Well, secant of tangent inverse of u plus cosine inverse of v. And I'm going to let this be alpha and this is beta. Okay, so let's draw a triangle. Tangent inverse is restricted in 1 and 4, but because I want it to be positive, so I can put it in quad 1. So here's alpha. Tangent is opposite over adjacent. So based on Pythagorean theorem, let's try that. Okay, so it's a squared plus b squared equals c squared. C squared is unknown, so 1 squared is 1, plus u squared is u squared equals c squared is unknown. Let's solve for c, so c equals square root of 1 plus u squared. That's where we're going to put this, 1 plus u squared. All right, so there's alpha. Let's draw beta. Beta's over here. Okay, here's beta. Cosine, it's restricted. Cosine inverse is restricted in 1 and 2. I want everything to be positive, so let's put it over here. Cosine is adjacent, which is v over hypotenuse. Okay, well, we kind of did this already over here. See this right here? So I know, based on my basic math over here, this is now 1 minus v squared for the opposite leg. So I'm dealing with secant, so I'm going to start with secant of alpha plus beta. But Mrs. Tran-Bloom, you never gave us any identity for secant. What the heck, hey? Well, I don't need to. Why should we all need to memorize another formula where I can just use something we already know, like cosine? Secant is 1 over cosine, and yes, it's the same, okay? So we just have to carry the 1 on top the entire way, okay? So let's keep on going. The identity for cosine is cosine of alpha, cosine of beta, minus, because you have to do, and then remember, you have to extend this line, otherwise it's not correct if you don't extend this line. So minus sine of alpha, sine of beta, okay? Then we find the cosine alpha plus beta normally and then just put it over 1. That's exactly all that is. So let's keep on going. 1 over, here we go. Cosine of alpha, alpha is my red triangle right here. It's going to be 1 over the hypotenuse. Oh no, the hypotenuse is ugly. Hypotenuse is radical 1 plus u squared. That's just cosine. Times cosine of beta. Cosine of beta is nice. It's adjacent as v over 1. Beautiful. Minus sine of alpha, back to the red triangle. Sine is u over hypotenuse, and there goes that ugly hypotenuse again. Okay, extend this line. Sine of beta, it's 1 minus v squared all over 1. Okay, so let's multiply this out. It doesn't look cute, but what choices do I have, right? It's 1 over, here we go. I'm going to multiply these, so let me highlight. 1 times v is just going to be what? V over my denominator of 1 plus u squared, okay, minus u times square root of 1 minus v squared. Write the v's and u's carefully, because if you don't, you will do the wrong math because we have to find common denominator if they're not the same. Oh, nice. Look at this denominator. It's already the same, right? So I can just 1 divided by, okay, put it all over the same denominator because it's exactly the same. Cool, right? Okay, so now on the top, it's just really v minus u radical 1 minus v squared. Okay, so 1 divided by anything, it's really like this. 1 divided by, all right, v minus u times square root of 1 minus v squared all over square root of 1 plus u squared. I can multiply by its reciprocal, so here we go. Well, if I multiply by its reciprocal, 1 times this is now just that, okay? So v minus u times square root of 1 minus v squared. Okay, so technically, this is an answer. Would you agree? If this is on a test and you get down to here, I will give you full credit, okay? Because look at that. That's just a lot of work already. So again, I'm just going to highlight this and tell you right now, if you are able to get to here, you will get full credit, okay? Now, if it's a multiple choice, you might need to rationalize your denominator. So this is the part where if it's a free response, the credit is full. If it's multiple choice, you need to be able to know how to rationalize to get to an answer with no radicals. So this is where I'm going to come in and multiply by the conjugate. Hopefully it's not some ugly answer. We'll see, right? Okay, so what I multiply to the bottom, I now multiply to the top. Okay, then now I'm just going to cautiously and carefully write down everything because I tend to make algebraic mistakes and I don't want to do it. Okay, so let's do the top one. The square root 1 plus u times that is going to be v in the front times square root 1 plus u squared. Square root of that times that is going to be an addition of u times 1 plus u squared times the square root 1 minus v squared. All over. On the bottom, because these are conjugates, I can just v times v is v squared minus u squared times radical 1 minus v squared times another radical 1 minus v squared. The radicals go away. So that's where I'm at right now. Okay, I'll pause a little bit so you can copy it down. Okay, so now we're just going to see if we can do anything to simplify, right? So let's check. This is v times square root of 1 plus u squared on the top plus, technically you can keep these two right here as their own radicals, or you can multiply and put it under one common radical like this. Okay, either way, they are the same. All over. Okay, on the bottom, v squared, I'm just going to distribute this, okay, minus u squared times negative u times a negative u squared times a negative v squared is positive u squared v squared. Well, not much you can do, so guess what? That is my final answer. Look how ugly that is, right? So that's why, like I said, I will give you full credit if you are able to get down to here. Okay, so this is okay. Either form / answer, it's okay. Okay, unless you are in multiple choice and they need to get rid of the radical, then you have to go further. Okay, this is the end of our example.